So we've been talking about systems, and systems means that there's more than one constraint that needs to be considered. So if we're talking about two equations, the point needs to make both equations true. If we're talking about just a word situation and there's no equations, you just have to make sure that both things are satisfied. So even though this Facebook thing includes equations instead of variables, it's got fruit pictures, you can use substitution very easily in this. You've got a clear piece of information right here in the first equation. If you know that there's going to be 3 apples that are 30, then each apple has to equal 10. Once you know that, then you can substitute that information in for all of the other apples and then use that to find what's missing. So if 10 plus 2 bananas is 18, then the 2 bananas have to equal 8, and you can go on from there. So a banana is going to equal 4, and then 4 minus a coconut is 2, so coconut has to be 2, and a banana is 4. So you're substituting what you know to figure out what you don't know. We can solve with graphing or from a table. So here we did this. If you watch the other video, it's the exact same thing. If we have graphed y equals x minus 2, the pen's not working. Y equals x minus 2, which is this one. All the points on y equals x minus 2 are right here, including when x is 0, y is 2. When y is 0, x is negative 2. You can pick any point on this line and put it in here, but we also know it grows by 2 each time. So, no, it grows by 1 each time, my bad. So like if we had negative 1, it would be 0 plus 1, and we already know that 0 is 2. So that's all those points. And then 2x minus 1, all of these points are going to be solutions to y equals 2x minus 1, but there's only one point where they're the same. So 2x minus 1 is 0, negative 1 is our starting amount because it's our y-intercept, and it grows by 2. So we can go ahead and we get 1, 1, and it goes by 2, we get 2, 3, etc. We could go backwards if we wanted to. Negative 1 would be 2 less, so it would be at negative 3, and sure enough, here it is, negative 1, negative 3. But the point that makes both of them true, the common point that makes both of them true, is 3, 5. So when you're solving with substitution, you're using the idea that if you know one piece of information in both of the equations, or one piece of information in one of the equations, it has to be true in the other one as well. So in this particular case, we know that y is equal to x plus 2, and y is equal to 2x minus 1. And y has to be the same thing in both places. So we can just set them equal to one another and solve for what x has to be, because it will make y the same thing in both equations. So I've set them equal to one another. When you have variables on both sides, you're going to have to go ahead and blow this up a little bit. You have to go ahead and decide where to start, and you can start anywhere. I'm just going to get rid of this x first, and so I'm going to subtract x from both sides. And so I'm going to subtract x, I'm going to subtract x. Remember, I'm only dealing things that are like terms. X minus x is 0, and the plus 2 is still there. And then 2x minus x is just x minus 1. And so I want to get that x by itself. Once again, here I am looking to get the variable by itself. So I have to get rid of that subtract 1. So I'm going to add 1 to both sides. And we end up with x equaling 3. Now we need to find what y is. And it's easy to go ahead and do that. All you have to do is continue with your substitution idea. I know what x is in one of them, and it's got to be the same x in the other one, so I can go ahead and just plug it into one of the equations to find out what, oh, I just said that wrong. I know what x is in both of them. Now I want to find out what the y is in both of them, but I only need to plug it into one because it should get you the stuff unless you've made a mistake. So I'm going to plug x equaling 3 into the first one. 3 plus 2 is 5, y is 5. And we can actually check in the second one as well. 2 times 3 is 6, 6 minus 1 is 5. Sure enough, our solution is the point 3,5, which in the previous slide we got that as well from the graph. So with this one, I'm going to talk about, once again, substitution. We want to find where these two lines cross, what's the common point, and they're not solved for one another. Now, for those of you that like to change this into y equals form, you'd end up with y equals -1x plus 5, and then you could set them equal to one another. That's fine. But if you don't do that or you want another method, here you go. We know what y is in one of them. And so we're going to go ahead and take that information and replace the y in the other equation with that. So here we have the second equation, 2x plus 2y. Well, we know that y has to be equal to 2x plus 5 because we're looking for when they're the same. So the first thing you have to do is replace the y or the x, depending on what's solved for, in the second equation, or in one equation, with the info from the first. I'll say it again. Here we go. We knew that y had to be 2x plus 5 in both of them, and so we're going to replace the 2x plus 5 for the y in the second one, and then we only have one variable to talk about. So I'm going to take this to the next page. If you know how to solve this and you don't want the steps, you can stop right now if you understand how to replace stuff. And you can just go ahead and start with the video. But if you want some help with how to solve this, I'm going to go ahead and do that in the next slide. So in the previous slide, we'd taken what we knew about y in the other equation, plugged it in for the y in the second equation, and now we just have to solve for x, and once we have x, we can solve for y. So we're going to go ahead and simplify this left-hand side first, and so we have 2x. We need to distribute this, and so we have 2x plus 5's, which mean we have 4 x's, and 2 5's is 10. And so we simplified. You always want to simplify each side first, and that means you might be dealing with like terms, and you might be dealing with distribution. So we've already distributed, so now we just need to put our like terms together. So we have 2 x's and 4 x's. That means we have 6 x's plus 10 equals 10. So then we're going to go ahead and get the variable by itself. That means we have to get rid of this 10. So we're going to subtract 10. And so minus 10 minus 10, we end up with 6x equals 0. So x has to equal 0, right? And then we have to go back to the original equations to help us to find out what y is. And so remember, our original equations were y equals 2x plus 5 and 2x plus 2y equals 10, I think. So we go ahead and take the information that we already know, substitute it in for what we don't know, and so y equals 2 times 0 plus 5, so y equals 5. This one happens to be, the solution is the y-intercept of both lines.